One of the major ways of making electricity without contributing to the climate crisis is through offshore wind.
There's no other way to get Northeast states to meet their climate change requirements.
Now, the U.S. has kind of been behind other developed countries when it comes to offshore wind.
The question is, are we going to deal with climate change? It's been kind of a binary question, right? Are we going to deal with this or are we not going to deal with this? And it's hard to break new ground. I mean, I've been actually working on this for 20 years. This is actually my 20th year trying to build offshore wind projects in the United States. And it's finally happening. We're finally building a project.
Vineyard Wind is the first commercial-scale offshore wind farm in the U.S. This is a special day. It's the arrival of the very first components of this first offshore wind farm.
On board, it'll have 6 towers. There are 3 towers in the hatch, 3 towers on deck. As it comes in, the first thing you notice is just the sheer size of it.
A lot of people have been working really hard for many years on this project.
You know, we've been waiting so long for this, and now it's here. I'd lie if I said I wasn't frozen in my steps for a sec. Now that it's in the U.S., it's just all hands on deck making it happen.
This is a huge day in climate history. These giant steel pieces are sections of the turbine tower. The tower is what rises up out of the water and holds everything up. Each tower is made with 3 of these stacked on top of each other. General Electric builds this turbine, the Halley 8X, and it was the largest turbine in the world when it came out.
The turbines are bigger than what we expected. You know, they're larger than the Eiffel Tower. And it's exciting to figure something out for the first time.
These pieces are huge. They're over 100 feet long. When the turbine is built, it will almost be as tall as the Chrysler Building in Manhattan. You can't even really tell the size of these things from the drone shots until you see the people walking around down there in the cars to give you some scale. There's a lot of really highly trained union members working to lift these things up. You have to be really careful because you don't want anything to go wrong when something this heavy is hanging in the air like that.
We're dealing with an awful lot of weight on this job, and there's a lot of things that can go wrong.
It's not as simple as, you know, just you pick it up and put it down. It's PhDs, it's a ton of engineering going in behind it. Every single calculation has to be spot on. We keep an eye on the weather. If conditions aren't right, we shut it down before it's even time to go out.
Luckily, these guys are super skilled, highly trained, and they know exactly what they're doing. They do all kinds of math and measurements before anything's even lifted up.
And that's why we have all the planning that goes into place to make sure that nothing goes wrong. So I'm confident that we're going to be able to execute our plans out here because we have enough good people out here that are involved in safety and looking out for each other.
The tower components are stored and organized in the marshalling port. A company called Black & Veatch manages the craft labor on site and does the equipment, mechanical, and electrical pre-assembly work before it goes to sea. Next, the blades and what's called the nacelles arrive at the port in New Bedford, coming up.